The Electrical System Control Panel, or ESCP, controls the Md11 electrical system and is on the overhead instrument panel in the flight deck. The electrical system also includes the bus reset panel, which is adjacent to the ESCP. This lesson shows the operation of the AC generator and the AC bus tie controls. The lesson includes the operation of the system switch, the 3 generator switches, and the 3 AC bus tie switches. The system switch is in the top right corner of the electrical system control panel. The system switch controls the automatic and manual modes of the system. In the automatic mode, the switch face is level with the face of the panel. This is the usual position of the switch. In the manual mode, the switch extends from the panel. The system switch is a push-button switch that lets the operator go from the automatic mode to the manual mode and back again. There are 2 lights on the switch: the select light and the manual light. The system usually operates in the automatic mode. If the automatic mode cannot adjust to the system's needs, the system will automatically go into the manual mode, and the select and manual lights will come on. When this indication comes into view, you must push the system switch to make the switch and the mode of operation agree. In this example, the select and manual lights are on. The system has automatically changed to the manual mode. You see that the select light goes out, but the manual light stays on. The system and the switch agree, and the system is in the manual mode. When you have corrected the problem, or when you want to put the system back into the automatic mode, push the system switch again. The manual light now goes out. This indication shows that the system has gone back to the automatic mode. The automatic mode is the usual mode of operation for the system. There is one other time that a light on the system switch will come on. The manual light on the system switch will come on and flash if you try to use a switch light on the panel that the system controls in the automatic mode. There are 8 switch lights on the panel that will cause the manual light to flash. These lights are the generator switch lights, the 3 AC bus tie switch lights, and the 2 DC tie switch lights in the DC electrical system. Look at the generator 3 switch light as an example. If you push the generator 3 switch when the ESCP is in the automatic mode, the manual light on the system switch flashes. The manual light will continue to flash until you release the generator switch light. The electrical system uses the system switch light to tell you that it cannot do that task in the automatic mode. When you release the generator switch light, the manual light on the system switch will not flash. The system stays in the automatic mode. Now that you know how the system switch operates, we will look at generator switch operation. The generator switch is a push-button switch with two lights, an arm light and an off light. The two lights supply important information about the generator's circuitry. This graphic shows the interface between the generator control relay and the generator relay. Each integrated drive generator supplies electrical power to its related bus. The generator connects to its bus through the generator relay, now shown on the screen. When the generator relay closes, generated voltage goes to the generator's related bus, where it is available to supply the system. When the generator relay is open, power cannot flow to the bus. There is one more relay in the generator circuitry, the generator control relay. The generator control relay must close for the generator to make voltage. If the generator control relay does not close, or if conditions cause it to open, the generator will not supply electrical power. When the generator control relay is open, the generator relay will also open. The generator control relay and the generator relay must close for the generator to make electrical power and to supply power to the AC buses. The off and arm lights on the generator switch show the condition of the two relays. When the generator control relay opens, the generator relay will also open. In this example, the two relays are open. This condition causes the off light to come on. When the generator relay opens, but the generator control relay closes, an arm light will show. This light is an indication that the generator relay is automatically controlled. The open relay stops the power. The power does not get to the generator's related bus. Because the automatic system controls this relay, the arm light comes on and goes out automatically. When the automatic system resets the relay, power can again flow to the bus and the arm light goes out. In usual operation, each generator supplies power directly to its related bus. Power then goes from these buses through the bus tie relay to the AC tie bus. If there is a generator failure, power will continue to go to the bus of the failed generator through the AC tie bus. The two good generators equally supply the electrical power with no stop in AC power. If there is a fault on the AC generator bus, the bus tie relay automatically opens to give the electrical system protection. This procedure isolates the defective bus from the remaining system. Also, the generator relay and the generator control relay open to isolate the generator from the defective bus. In this graphic, bus tie 2 opens and isolates generator bus 2 from the bus tie system. The bus tie will stay open until you push the bus fault reset switch light on the bus reset panel. The mask over generator 2 shows that it has stopped operation and will not make power. On the electrical panel, the arm light on the AC tie 2 switch is on. Also, the off lights on the generator 2 switch, the AC ground bus, and AC generator bus 2 will be on. The off lights show that the generator has protection from the defective bus. The AC tie switch light and the generator switch light operate in the same way. The AC tie switch light has two indicator lights, the arm and the off lights. The arm light shows that the AC bus tie switch is open because of the generator control unit. This condition occurs when the auxiliary power unit, or APU, is on, or when a fault occurs in an AC generator bus. If the generator control unit can correct the problem, the arm light will automatically go out. The off light comes on when the system select switch is in the manual mode and the AC tie switch is set to off. The only procedure to reset the off light is to push the AC tie switch light while the system is in the manual mode of operation. Thus, you must first put the system into the manual mode. If you push an AC tie switch light while the system is in the automatic mode, the manual light will flash. This indication tells you to set the system to the manual mode. The manual light on the system switch flashes. This indication shows the operator that the system can only do the given command in the manual mode. With the system in the automatic mode, the system cannot complete the task. First, set the system switch light to the manual mode, and then set the AC tie switch. If an AC generator bus failure occurs, you will use the bus reset panel to reset the generator bus. To reset the generator bus, you will push the correct switch light on the bus reset panel. In this example, you will push the bus 3 fault switch light. If the bus resets, the bus 3 fault light will go out. If the fault stays there, the light will stay on. You now have the primary facts about the AC power system and its operation in the manual and automatic modes. Although the system usually operates in the automatic mode, there will be times when you must operate the system in the manual mode. We talked about the system switch with the select and manual lights, the automatic and manual modes of operation, the generator switch lights, and the bus tie system and components of the bus tie circuitry. The important fact to know about the electrical system is that while most operations are automatic, you can and must find and identify malfunctions and then take the necessary actions to correct the situation. In subsequent parts of the lesson, we will identify and correct specified malfunctions.